Measuring disease occurrence, incidence, and prevalence. How do we measure diseases? There are 4 quantitative descriptors to measure disease occurrence. We can quantify disease either using numbers or ratios or proportions or rates. Numbers, we use the actual number of events. For example, there are 100 cases of tuberculosis in community A. Very simply. The other quantifier is ratios. Ratios quantifies the magnitude of one occurrence X in relation to another event Y, as X to Y or X divided by Y. For example, ratio of TB cases in community A to community B is 1 to 10. Community A and community B are separate and different communities. Third is proportions. What is a proportion? A proportion is a ratio in which the numerator is included in the denominator. Numerator هو البسط والdenominator هو المقام. What is different about proportion is that the numerator is part of the denominator. For example, if we say proportion of TB cases in community A is 10%. 10 divided by 100 and usually expressed as a percentage. So number of cases of tuberculosis in community A divided by the number of people in community A. The fourth quantifier is rates. A rate is a proportion, but what's different that it has time element into it. So a proportion with time element. It measures occurrence of an event during a period of time or over time. For example, we can say the US measles cases in year 2000 divided by US population in the year 2000. So it's during 1 year. Number of cases of measles divided by population. It's just like a proportion. It is a proportion, but it should have a time element or a period during which we are measuring the proportion of disease. This is what we call rate of the disease. Measurement of disease occurrence, morbidity measures. Morbidity refers to cases of disease in a population. Morbidity rates are rates that are used to quantify the magnitude or frequency of disease in populations. There are 2 common morbidity measures: incidence rate and prevalence. For incidence, there are cumulative incidence and there is incidence density. We are only going to look at, in this lecture, at cumulative incidence. That's the very simple incidence to calculate. Prevalence, there is period prevalence and point prevalence. We will look at only point prevalence here for simplicity. Incidence rate. Incidence can be defined as the proportion of a population that develops a disease over time. Incidence of a disease is also the risk or the probability of an individual developing a disease over time in a certain population. Also, we can define incidence rate as the rapidity with which new cases of a disease develop over time. Also, incidence is the proportion of unaffected individuals who on average will contract the disease over time. These all define incidence rate. Cumulative incidence. How do we calculate incidence? Incidence can very simply be calculated by dividing the number of new cases of a disease in a population during a specified period of time divided by the population at risk in the same period of time. Incidence can be understood as in this figure here. This is a bathtub where the tap with running water. Incident cases are new cases of disease occurring in this population. New cases are the incidence. There are some practical challenges in measuring incidence rate. They all relate to the population at risk. What does that mean? First, identification of population at risk. Population at risk constitutes all those free of the disease and are susceptible to get the disease. Second, population is not static. As you have learned in demography, populations change over time constantly. Populations fluctuate as a result of births, deaths, and migration. So we should know the size of the population at that period of time during which we are calculating the incidence rate. Third, people are only at risk until they get the disease. If they get the disease, they will no longer be more at risk. So people who get the disease, they are no longer at risk. They will be subtracted from the denominator. They are not at risk anymore. Prevalence. What is prevalence? Prevalence measures the proportion of a population with a disease during a specified period or at a point in time. If we go back to the example of this bathtub, we said earlier that incidence is the flow of new cases of disease in this population. Prevalence is all accumulated cases over time, all people who live and survive with the disease in this population, accumulated all together, they constitute prevalence. Prevalence measures the proportion of a population with a disease at a point in time. This is point prevalence that we are going to see here. How to calculate prevalence? Very simple. It's number of all persons with a disease in a population at a certain point of time divided by the total population, regardless of being at risk or not. So it is not a rate, but it is a true proportion. It is a very common mistake to say prevalence rate. Actually, prevalence is not a rate. It's just a proportion because there is no time element embedded in calculating prevalence. This figure shows the relationship between prevalence and incidence. Incident cases are what? Are the new drops coming into this barrel. The more or the higher the incidence, the more water will be or liquid will be getting inside this barrel. Prevalence, on the other hand, is what? Is the accumulation of all cases of disease living in this population, that is, all drops of water accumulating in this barrel. The higher the incidence rate, the greater the prevalence will be. Also, we can see the duration. The longer people live with this disease, if disease is chronic with high duration, the more people that can be found in this population whenever we want to calculate prevalence. Right? We can also notice here the leak. Drops that are coming down the barrel and out of the barrel down there. Who are they? What are the cases that are getting out of the pool of prevalence? They could be people who get cured, who had the disease and got treatment and got cured. Now they are no longer cases. This is one of the leak reasons. The other case is deaths. People who die will not be calculated in the prevalence, will not be found in the population when we calculate prevalence. And there are some people who may be lost to follow-up, or we lose track of them. We cannot find them to determine if they are still in the population or if they still have the disease. We don't know about them. So in this way, we can imagine or visualize what is incidence and prevalence and the relationship between them over duration or a period of time. So the relationship between prevalence and incidence rate. We can say that an increase in prevalence may not necessarily be due to increase in incidence all the time. An increase in prevalence could happen because there's an increase in average duration of the disease. People are living longer with the disease due to decrease in death rate or recovery rate. So don't forget, prevalence equals incidence rate multiplied by average duration of the disease. So if a frequency of the disease is rare, that is less than 10% of the population has it, and average duration of a disease remains constant, then preventive measures that will reduce the incidence or reduce occurrence of new cases because of prevention of disease, that would be expected to result in decreased prevalence. Similarly, if the incidence remains constant, then developing a cure means that people will live shorter period of time with the disease. That would reduce the average duration of a disease. That would also reduce prevalence of a disease. On the other hand, there's the example of what happened with HIV. In the late 1990s, antiretroviral therapy was introduced and greatly improved the survival of people with HIV. People who used to get HIV infection, they died more quickly. But with the antiretroviral therapy, they get treatment and they are surviving for a very long time. However, they weren't cured, so they are still cases living with the disease. They have HIV, but living for much longer time. This means that the average duration of disease has increased greatly. That resulted in increased prevalence of HIV during that period around the world. So increased prevalence, not because more incident cases are happening. No, there was prevention, but because duration of the disease increased greatly. Now some calculations. Let's calculate together prevalence and then incidence rate. This is a survey of respiratory disease that was conducted, and results are presented in this table below. We need to calculate the prevalence of chronic bronchitis, first in each age group and then in the total population. Population here is the population of study, this group of people. So this is prevalence of chronic bronchitis by age in a sample of 2,383 employed men in 1981, divided by age groups, and we have number surveyed in each age group. They totaled up to 2,383. We have the frequency of disease in each age group. To calculate prevalence in each age group, we very simply divide the number of cases in that age group divided by the number of people in that age group. Let's calculate together the prevalence of chronic bronchitis in all this group of employed men. Prevalence of chronic bronchitis here is the total number of cases, that is 54 cases, divided by the total number surveyed, divided by 2,383. That would give us 0.0226. If we want this as a percentage, we should multiply by 100%. We'll get 2.3%. So prevalence of chronic bronchitis in this group of people is 2.3%. We can also use another multiplier. If we multiply by 1,000, this will equal 22.6 cases per 1,000 population. If we multiply by 1,000, we will get number of cases per 1,000 population, and that would be the prevalence. So it is very simple to calculate prevalence. Now let's calculate together incidence rate. A study was conducted to examine the incidence of carpal tunnel syndrome among computer operators in a certain corporation. An initial survey was given to 12 administrative assistants. We found 2 of the 12 administrative assistants already had symptoms of carpal tunnel syndrome, and 10 of them were healthy, free of that disease, and did not reveal any signs or symptoms equivalent to carpal tunnel syndrome. The administrative assistant who did not reveal signs and symptoms were then recruited into a study and followed up for 4 complete years. The findings are listed in the table below. Over the 4-year period, 3 out of the 10 administrative assistants developed carpal tunnel syndrome during the 4 years of follow-up. So we can see that the two persons who were at the start of the study, they had signs of the disease. They were not included in the disease because they are not at risk. We need to start with healthy people and follow them up over time and watch occurrence of new cases of disease developing. So we monitored the 10 people who were free of the disease. So 3 of them developed the disease, and here we need to calculate cumulative incidence per 1,000 population. So cumulative incidence very simply is 3 divided by 10. 3 out of the 10 people surveyed or followed, not surveyed, followed up over time, developed the disease. 3 divided by 10, it's 0.3. It could be expressed as a percentage, that would be 30%. It could also be multiplied by 1,000 or 100,000. By 1,000, this will give 300 cases per 1,000 population. And this is very simply how we calculate incidence. The one thing we have to keep in mind that the population followed to calculate prevalent incidence, should be free of the disease and at risk of developing the disease at the start of follow-up.